Hi, I'm Dick Seitz. Welcome to the Software Screw-Up series, based on the screw-ups index entries in my Understanding Software Dynamics book. Today's episode 12 is about the GCC compiler. So you're probably all familiar with this kind of math or magic trick where you tell somebody to pick a number from 1 to 10 and then do something. In this case, multiply it by 2, multiply that by 5, divide that by the original number, subtract 7, and I, Richard the Magnificent, will guess your answer. It's 3. Of course, if you look at the process, starting with x, multiplying it by 2, multiplying that by 5, dividing that by x, x is gone. You always get 10. Subtract 7, you always get 3. It's just a way of obscuring simple things. So you see the same thing with good software, in particular good compilers. Here's a real benchmark loop that's very old, that starts with j is 1, k is 2, l is 3, has a loop around, does like a million times. 2 multiplies, 2 subtracts, 2 more multiplies, 2 more subtracts, multiply, subtract, and add. A couple adds, a couple multiplies, a couple subscripted stores. Is trying to measure how long do a bunch of multiplies and adds take. Here's what GCC does when you look at it. It does constant folding. So the first time around it says, oh, j is 1, k minus j is 1, l minus k is 1. Multiplies together, you get 1. J is 1. Go around again on k. K is l times k is 6. L minus j is 2. K is 2. 6 minus 4 is 2. K is 2. L minus k is 1. K plus j is 3. 1 times 3 is 3. And then the stores store just 1, 2, and 3, or 1, 2, and 3 multiplied. So that's the first time around the loop. And of course, j, k, and l are loop constants. And so the compiler can move these 3 lines back out of the loop entirely, at which time the loop simply becomes E1 sub 2 is 6, E1 sub 1 is 6. In fact, if the optimizer had done a little more work on constant subscripts and arrays, it might even gotten rid of these. But there's nothing in this loop now that's measuring adds and multiplies. That's the whole point, that you have to be careful when you're measuring stuff to see that what you're actually measuring is what you intend to measure. In many cases, when you look a little deeper at what's going on, it's not what you're intending to measure. Thank you for watching the Software Screw-Up series. Tune in again soon. Take care.